Good morning, learners. My name is Mr. Paul Chilola once again. Welcome to BLACKSLIDES Online Secondary School. This is your place where you learn the sciences, namely physics, chemistry, biology, mathematics, and the agriculture. Welcome, learners. We meet now to explore a concept called pressure, as used in physics. So we shall explore the concept called pressure. The concept used in physics. Welcome, learners. If you are watching on this video lesson on our YouTube channel, consider subscribing to the channel and also hit the notification bell. This will help you to get notifications every time we upload new material. Welcome, learners. We may also explore the possibility of joining our main classroom, where all subjects are offered at competitively low fees. In order to do that, just send us a text message on WhatsApp to the number shared here. Welcome, learners. Invite your friends, as many friends as possible, to join us, either by subscribing to this channel or joining us into the main platform. We would like to reach out to as many students as possible. For now, we are enrolling students for the holiday lessons, which already started on July 1st, and we are going to continue teaching up to the end of the holiday, the long holiday. So if you are in Form 3, you have just written JC exams and you're waiting for results, consider subscribing to this channel and also join our main platform at a competitively low fees. Welcome, learners. Welcome to this lesson. We are going to explore a concept called pressure, as used in physics. So this is Form 3 Physics. Welcome, learners, to BLACKSLIDES Online Secondary School. Spread the word, inform your friends wherever they may be to join us. Inform them that it's possible to learn on this platform and prepare for your MSCE exams. It would please you to note that our learners come from different countries as well. We have students in Kenya. Welcome our Kenyan students. We have students in Namibia, in Uganda, South Sudan, and the other parts of Africa. We also have students in the Middle East. And we are glad to be the part of your success story. Welcome, learners. You can make requests as students. You are free to make requests, to ask for notes and the other related materials. Welcome, learners. So we are exploring a topic called pressure, the concept of pressure as used in physics. Right. So the term pressure is used in everyday life. You might hear people who say they're under pressure to do something. Or you might also use the word pressure to mean different other things. But in physics, we are going to look for a unique meaning of what it means by pressure. Welcome, learners. So before we explore the meaning of pressure fully, or get to the meaning of the concept pressure, I want you to understand the concept pressure. So in order to understand its meaning, the meaning of pressure, I want you to consider the following examples of experiences with force on solids. These are everyday experiences which I would like to share with you. Either you or another person who you have seen, a person makes deeper marks while walking on soft ground in high-heeled shoes than in flat shoes. Shoes can be classified into two groups depending on the length or the height of the heels. So there are high-heeled shoes and flat shoes. So a person makes deeper marks while walking on soft ground in high-heeled shoes than in flat shoes. Consider this lady, for example, who is walking to work or to office on a muddy ground. So as she steps onto the ground, walking to work, this shoe has a high heel. As she is walking, she presses down on the muddy ground and makes a deep hole into the mud, and continues to walk like that. Of course, experience will show that this makes walking difficult in the mud on the soft ground. It's very sharp. The heel is very sharp and makes a deeper mark onto the ground. Unlike this gentleman who is also walking to work, the heel, by the way, heel is this bit here of the shoe, this part here. This is flat, while this one is high-heeled. This is short and flat. It makes a shallower mark compared to this one here, which makes a deeper mark. So we are saying a person makes deeper marks while walking on soft ground here than when walking on flat shoes, while wearing flat shoes. So the mark made by a flat shoe is shallow. So I want you to think about this This one here is sharp and it has a smaller area of contact with the ground, while this one is not sharp, as flat. This makes a deeper mark because it has a smaller area of contact. This one makes a shallower mark here because it has a larger area of contact with the ground. Welcome, learners. This is a daily experience, one of the daily experiences. I'm sure if it can be you, it could be you experience this while walking to school wearing a high-heeled shoe or a flat-heeled shoe. The experience is different. If you're wearing a high-heeled shoe, you make deeper marks into the soft ground than when you wear flat shoes. Mostly this happens with ladies who like to wear high-heeled shoes, and like males who prefer to wear flat shoes for some reason. Another experience is seen when you're pushing a sharp pin through a cardboard, or when you are pushing a blunt one through the same cardboard using the same force. This is a cardboard, a piece of wood, and this is thumb. So the thumb is exerting a force on the sharp pin. The sharp pin penetrates into the wood, to the cardboard. Here we are referring to a cardboard. So it's important that we stick to using cardboard rather than wood. So suppose this is a cardboard material. We're pushing a sharp pin into the cardboard. It penetrates deeper into the cardboard. But when blunt is the opposite of sharp. Blunt means not sharp. So when the same force is exerted on a blunt or not sharp needle or pin, it seems there is struggling for the blunt pin to penetrate through the material. It goes back to the same. A sharp pin has a smaller area at the tip there, enabling it to exert higher pressure. Hence, it goes deeper into the material. And like this, it has a bigger area here at the tip. Applying the same force leads to exertion of a smaller pressure. Therefore, it doesn't penetrate much. These are daily experiences. There are many other examples you can think of. You can think of tractors with larger tires being able to move on a muddy road, but another car with smaller tires gets stuck in the same mud. It has to do with pressure, size of pressure, and size of area. Think of many other examples. A sharp knife cuts tomatoes much easily than a blunt knife. What's the reason for that? It's to do with size. of area of contact between the knife and the material being cut. These are daily experiences. When you stand on the ground, the weight of your body pushes on the area on the ground. All those are everyday experiences of pressure. Welcome, learners. So, in all these cases, a given force acting on an area causes a penetration, something getting into a material. It may also cause a depression or distortion on the material in which the force is acting. So think of different other cases where a force is exerted on an area and causes either penetration, depression, or distortion of the material on which the force is acting. Welcome, learners. It is pleasing for us to be with you. Our joy is found in the fact that we are helping you to learn in order to prepare you for your MSCE examinations if you are in Malawi, or KCSE exams if you are in Kenya, and other exams elsewhere. Welcome, learners. Don't hesitate to contact us so that we can have a thorough program for you to help you, to teach you. Welcome, learners. So these are daily experiences of forces. All right, so let's look at pressure in much greater detail. From the examples we've looked at, it is clear that the effect of pressure of a force is greater when the force acts on a small area, as in high-heeled shoes and a sharp pin, than when it acts on a larger area. Welcome, learners. So in general, when a force is applied on a given area, pressure is exerted on that material, on the surface of that area. Right? So pressure is exerted. You can say pressure is being exerted. So you see now the concept of pressure is coming out clear in physics, in the context of physics. It's getting out clearer in the context of physics than in other contexts. Like when the word pressure is used in English, in everyday speech, it may mean something else, like maybe someone trying to force you to do something. That's pressurizing. When you are under pressure, it means there's some kind of influence, but the physics term, pressure, as used in physics, has to do with force acting in a given area. Welcome, learners. So let's define the term pressure. Defining the term pressure. In your exams, you'll be required to define the term pressure. What is pressure? In a 1-mark question, in your MSCE exams or in your KCSE examinations, you'll be required to define the term pressure. What is pressure? Well, we shall define pressure in the following manner. So let's explore the meaning of pressure together. We shall strictly adhere to the definition given here. Pressure is defined as the force acting normally or perpendicularly per unit area. Alright, so we talk of pressure in relation to force being applied at 90 degrees to the area. Perpendicular means 90 degrees. So the force and the area of contact must be at 90 degrees to each other. Normally means perpendicularly or at 90 degrees. I've seen short definitions of pressure, like force per unit area. Yeah, that's all right. It's correct, but it lacks really the actual essence, the actual meaning of pressure. If the force being exerted is not perpendicular to the area of contact, then we have not done justice to the meaning of pressure. Okay, because the force may be at another angle other than 90 degrees, then that is not pressure. That's why if you're doing higher physics, you'll be required to resolve to find the perpendicular force by resolving maybe vectors, since force is a vector. So you may try to get the 90-degree component of the given force. So in that case, so take note of this. So force pressure is simply force force acting perpendicularly or normally. Normally means 90 degrees per unit area. That's the definition of pressure, learners. Welcome to this platform. If you have not subscribed to this channel already, consider subscribing so that anytime a new material is uploaded, you become the first one to know. Welcome, learners. Inform your friends that it is possible to learn here on Black Slides Online Secondary School channel, or you may also consider the option of joining our main classroom at a small fee. To do that, just send us a message to the number that we shared earlier on. That way, you are going to be guided through. So this is the definition of pressure. Pressure is defined as the force acting normally perpendicularly per unit area. Don't use both the normally and perpendicularly in the same definition. You either say normally or perpendicularly. So pressure is defined as the force acting normally per unit area or perpendicularly per unit area. So choose either normally or perpendicularly, but not both. It will be like you are repeating. You are talking about the same thing. So it's a force acting at at 90-degree angle per unit area. That's pressure. So from the definition, we can obtain the units of pressure using the definition. You remember that pair, the word pair means you are dividing something by something. So in this case, means that pressure can be found by dividing the units of force, the force acting by the area. Force divided by area. Pair means divide something over something. That's the meaning of pair. Alright, so units of pressure. Welcome, learners. So from the definition, which is this one here, we are saying pressure is defined as the force acting at 90-degree angle per unit area. So from this definition, it is clear that pressure P is equal to force F divided by area. Every time you have the word pair in a definition, it means something is being divided by another thing. So pressure is equal to force divided by area. So this will help us to find the units of pressure because we are dividing the we are dividing the units of force and the units of area to find pressure. So therefore the SI unit of pressure is going to be equal to the SI unit of force, which is the Newton, by the SI unit of area, which is square meter. So it's like you're dividing newtons by square meters. That will give us the SI unit of pressure. Welcome, learners. Invite your friends to our online lessons and join us on our classroom so that you can learn as much as you want. So since we are dividing the SI unit of force, remember the SI unit of force is Newton and the SI unit of area is square meter. We are dividing newtons by square meter. Therefore, this is the SI unit of pressure. This can also be written as Nm to the power minus 2. It's the same. These are essentially the same. When you see a minus power, it means pair. This means pair. So this is Newton per square meter, or Newton per square meter, written as Nm to the minus 2. Welcome, learners. Invite your friends, wherever they may be, to join us so that they can also benefit from the same. So the SI unit of pressure is therefore Newton per square meter, which is written as Nm to the power minus 2. The Newton per square meter is also called Pascal. Some say Pascal. It's alright. What is important for me is how you spell it. It's Pascal. So 1 Newton per square meter is the same as 1 Pascal. So in your calculations, mostly, you need to leave your answer either in Newton per square meter or in Pascals, because both of them are SI units. Both of them are SI units. Of course, when you take higher physics, you'll be required to write this in what are called the SI base units. You have to do some dimensional analysis The Newton is mostly the kg per meter squared. It's mass times acceleration. So kg per meter squared is the SI base units, and then you take meter, which is already base unit, multiply, you find the pressure in SI base units, but that's not the business at the moment unless you're taking higher physics. It requires you to present your results, your answer in your units, in the base units. Invite your friends to join us. So other units of pressure include the millimeters of mercury. You see these units quite a lot, especially when you're dealing with atmospheric pressure. Millimeters per millimeters of mercury, or sometimes the centimeters of mercury. Standard pressure is usually given as 760 millimeters per of mercury, or 76 centimeters of mercury. It can also be in units called atmospheres, in short written as ATMs. The relationship between a Newton per square meter and a Pascal, as well as the millimeters of mercury and the centimeters of mercury, as well as the atmosphere, will be met somewhere as we are looking at atmospheric pressure. You'll be shown the relationship between Pascal and these other units. Welcome, learners. Having looked at the definition of pressure and the units of pressure, it is very important for us to look at an example which involves calculations, because we define the pressure in a mathematical way as the force acting for a unit area. So we can look at an example just to help us master the use of the definition and the equation for it. So let's look at this example together. We are told that a man of mass 84 kgs stands upright on the ground. It is important for us to say upright because this will give us a hint regarding the force that the man is acting on the ground and the angle at which that force is acting. So this indicates that the man is exerting a force which is his own weight at 90 degrees to the floor. So upright. If he is not standing upright, it means the angle at which his weight acts on the floor is something else. And it may not fit into our definition of pressure. Remember that pressure is force acting normally or perpendicularly to on a given area. So the word upright is very important. Of course, there are some people who don't stand upright. They will bend, they will do this, twist, for some reason. But now, assume that this man is standing upright, so that the angle between his weight and the floor is 90 degrees. This is nice. Alright, so if the area of contact of his shoes and the floor is 420 square centimeters, 420 space If the area of contact of his shears and floor is 420 centimeters squared, okay, I think here there's no need for us to put the minus sign. Yeah, since we're just talking about area, so remove this minus sign. Let's just call it square centimeters because we are talking about area. So there's no need for us to say per there. Take note that this is just centimeter squared, not per centimeter. Alright, so this is the area. Determine the average pressure he exerts on the floor. So we are told the mass, not the force. Okay, remember pressure is force divided by area. We're given the area in the units which not square meters. Right, remember pressure is the force divided by area when area is in square meters, but this right now the pressure given here is in square centimeters, so we shall see what we do about it. So determine the average pressure he exerts on the floor. Take G to mean 10 newtons per kilogram. This minus means per kilogram. Welcome, learners. So it is important to figure out the data that is given. So we are given mass and the area and also the value of G. So what do we have to do with this in order to find pressure? Whatever the case, we must treat these so that they fit into our definition of pressure. Remember, pressure is force divided by area. But are we given force? No, we are not. We are given mass instead, and we are given the value of G. The area, yes, we are given, but it's not in the units that conform to the definition of pressure. So we shall also need to do some treatment on the units of area. Welcome, learners. All right. So from our definition of pressure, we said pressure is force divided by area. But the question has not given us, the statement has not given us the force. So we need to find force on our own. We shall use the fact that force is equal to weight of the man. Remember, it is the man acting on the area, on the floor. So the force, therefore, which is acting on the floor is the man's weight. Remember that weight of a body is mass multiplied by acceleration due to gravity, or what is called the gravitational constant. So you shall take the value of G multiplied by the value of the mass. Therefore, the force is 840 newtons. Very good. Once again, this area must be in square meters, not in square centimeters. So we need to change the given area, which is in square centimeters. We should change this into square meters. To change square centimeters to square meters, you divide by 10,000. That's an exam tip for you, because there will be occasions when you are given the area in square centimeters or other units. For now, I'm telling you that to change square centimeters to square meters, divide by 10,000. So the given area therefore is the same as 0.042 square meters. So we have the force there and we have the area down here. Now we can go ahead to define pressure. Pressure is force, which is the weight, divided by the area. The area changed into square meters from square centimeters. Welcome, learners. Right, thus the pressure is going to be 840, which is the weight of the man, divided by the area of contact. Alright, so I think we're trying to avoid using calculator here. So this multiplied by 1000, down here multiplied by 1000. We are doing this in order to have whole numbers both on top and at the bottom. So multiply this by 1000 is going to give us 42. Dividing the top number, the numerator, by 1000 is going to give us 840,000. So 840,000 divided by 42 is 20,000 newtons per square meter. So that's the pressure. Remember that pressure can also be given in pascals, using the fact that 1 newton per square meter is equal to 1 pascal. That means this is as good as 20 pascals of pressure. Welcome, learners. If you have questions regarding this example, don't hesitate to come back. Leave a comment in the comment section below, and we shall be glad to attend to you. Or just send us a message. We should be able to address the question. Welcome, learners. Let's look at another example. Example number 2. Metallic block of mass of 40 kg exerts a pressure of 20 newtons per square meter on a flat surface. Determine the area of contact between the block and the surface. So as usual, we need to look at the given data here. We're given kgs, 40 kgs of mass of block. So a metal block is placed on the floor, on the flat surface. The flat surface has a... Okay, so the block is exerting a pressure. Okay, so we are given pressure. We're given pressure and given mass. Okay, so using the mass, we can get the force, which is equal to the weight of the metallic block. And we are asked to find the area of contact. So quickly, we shall get weight, which is the force, by multiplying the mass by 10, and then divide that by 20 to find the area. Welcome, learners. Alright, so we're given mass and the pressure. First, to determine the area of contact area. So first of all, we need to find force. Force is obtained from mass because force is equal to weight of the block. So in this case, we take the mass of the block multiplied by 10, which is this one here, the gravitational constant. So 40 multiplied by 10 is 400. So the force being exerted normally or perpendicularly to the floor, to the flat surface, is 400 newtons. We have found the force. Force is 400 newtons, but we are required to find the area of contact. So for us to find the area, we shall need to play around with our equation of pressure. Remember, pressure is force divided by area. So making area the subject of this formula, we shall have area equals to force divided by pressure. Okay, so just divide. So divide 400 newtons by 20, which is equal to 20 square meters. So that's the area. That's how you go about solving this problem. Don't hesitate to contact me if you have questions. Welcome, learners. Let's look at example number 3. Example number 3 is saying a brick 20 centimeters long, 10 centimeters wide, and 5 centimeters thick has a mass of 500 grams. Determine the pressure, the greatest pressure that can be exerted by the brick on a flat surface. Suppose the brick is put on a flat surface. What would be the greatest pressure that the brick can exert on the flat surface? Sorry, and also determine the least pressure that can be exerted by the brick on a flat surface. And in both cases, we shall take G to be 10 newtons per kilogram. So when does greatest pressure exist? It exists when the small area exerts on when a force exerts on a smallest area. As we saw in the case of high-heeled shoe and flat shoe, as well as sharp pin and a blunt pin. So for us to get the greatest pressure, it means that the force is acting on the smallest area of the brick. And the least pressure will be found when the brick is acting, the largest area of the brick is acting on the ground, on the surface. Alright, so dimensions of the brick, first of all, we must change them into meters. Remember that definition of pressure is based on the meter rather than the centimeters. So change centimeters to meters, just divide each one of them by 100. So divide by 100 throughout, you have these dimensions. So the length will be 0.2 meters and the width will be 0.1, while the thickness will be 0.05. We go ahead to find the weight of the brick, which is the force acting on the given area. So weight of brick is equal to its mass divided by 1000. We are doing this in order to change the grams to kilograms. So we're given 500 grams. We change that to kilograms by dividing by 1000. And then you multiply by the value of G, which is 10. So this is basically mass in kilograms. So multiplying through give us 5 newtons. So the weight of the brick is 5 newtons. So from the formula, pressure is equal to force divided by area, we want to find the greatest pressure. We said that for us to find greatest pressure, It means we should divide this force by the smallest area. Right? So pressure is greatest when area A is smallest, like I said. So area of the smallest face of the brick is 0.1 times 0.05. Just take the smallest dimensions of the brick. So find the area. So the area will be 0.005 square meters. So pressure is equal to force divided by smallest area. Dividing the force, which is the weight, by the smallest area will give us a pressure of 1000 newtons per square meter, which is the same as 1000 pascals or 1 kilopascal. Let's say 1000 is a kilo. So take note of this. Pressure is least when area is greatest, so we do the same. So pressure is going to be equal to the weight divided by the greatest area. So the greatest area of the brick is 0.2 times 0.1. So the pressure is going to be 250 newtons per square meter, which is 250 pascals. Thank you very much, learners. Before I go, I would like to leave you with some work to do. And as usual, I expect you to do this work and submit to me to check. But the principle, the methods are the same. You just use what we have discussed to answer these questions. You should be able to do that. These are exam style questions. Number one is saying a force of 100 newtons is applied to an area of 100 millimeters square. Determine the pressure exerted on the area in newtons per square meter. Oh, so here we are given the millimeters instead of meters, so you have to change this. You have to change this to meter square. Meter divided by 1 million, because 1000 millimeters makes 1 meter. So divide by 1 million. Divide this by 1 million. If it was centimeters, you divide by 10,000. Okay, so change this to meters and then you divide into that. That will give you the pressure in newtons per square meter. A girl standing upright exerts a pressure of 13,600 newtons per square meter on the floor. Given that the total area of contact of shoes and the floor is this much, determine the mass of the girl. Alright, so we're given pressure here in the area. That means you need to find the force first. The force is going to be the weight of the girl. And remember that weight is mass times 10. So in order to find the mass, first of all find the weight using the formula of pressure. The weight is the force is basically the weight of the girl. So the weight you find divided by 10 to give the mass